Very good morning, guys. Today we are solving the problem paths to origin. So basically what this problem is, you will be given a coordinate, and from that coordinate on the x-axis or on the y-axis, you have to reach the origin. You have to reach the particular origin. So what is the origin of a graph? The origin of a graph is 0 comma 0, or the starting position. So you have to reach from a particular point to the origin, and what you have to return is the number of possible paths from your particular path to the origin. Now there are some constraints that you can either move left, means whenever the coordinate is, suppose the coordinate is x comma y, so that coordinate can move on the left direction, or the coordinate can move on the top direction. Okay, so in order to reach the particular point or the origin, so you will see there are some constraints x and y, which is the x comma y coordinates, and output is the number of path which is used to reach the origin. So for the second example, we have x equals to 3 and y 6, and the number of total possible paths is 84. Lastly, we have to return the answer to the modulo of this particular value. So I have visualized this problem in this image. So you can see in this image, this is looks like a graph, and this is x comma y, and these are the constraints. So what are the constraints? First, we are allowed to move left. Okay, we are allowed to move up, and we are allowed to move in x comma x minus 1 comma y, or x comma y minus 1. So whenever x minus 1 comma y is here, so you can understand the left component is variable, means next component is dynamic in nature and left component is changing. And whenever it is x comma y minus 1, the right component is variable and dynamic, so y component is changing, and that's why y component is responsible for taking the graph to the top, because y axis is the top axis. We have to find the number of paths from the points to the origin and return the paths modulo of this particular value. So this is an interesting problem of DP. So what we are going to do is, first the question is given as static int ways, right? So first we are going to do the ways. So for int I equals to 0, I less than equals to x, I plus plus. So we have to make a paths array which will store the paths. So I can write like this: paths, this is the paths array, equals to new int. So what can be the size of this array? So x plus 1, y plus 1. Okay, so this can be our size of the array, size of the paths array. Okay, now what is this loop for? X-axis denotes moving towards left. So while moving towards left, we are going to take the paths value, and the paths value of I of 0 equals to 1. So in this way the paths will move towards the left. Similarly, we are going to do j loop, j equals to 0 less than equals to y, sorry, j plus plus. So here the paths value, what will happen with the paths value? So you can take this as 0 comma j equals to 1. So I can write like this: denotes moving towards top or y-axis or up direction. Okay, lastly we are going to solve for the remaining points. So for remaining points, we are going to declare a nested loop less than nested loop. We are going to declare a nested loop plus plus for int j equals to 1, j less than equals to y, j plus plus. And inside this nested loop, we are going to compute the possible paths. So the possible paths can be I of j equals to, possible paths can be paths of so we have to take the sum, right? To calculate possible ways, we have to take sum of left plus top. So what is left? Paths of left is basically I minus 1 and j. So I can write this I minus 1 and j. This is the component for left. And for the second component, parts of, I can say, I and j minus 1 for the top component. So once this is done, I have to return the answer to the modulo value, right? So I can write over here static int mod equals to what is the particular modulo value given in this question? 1 into this question. So you can put the modulo value over here, and then after computing the sum, I can return the parts of modulo. Finally, I have to return the parts which is the coordinates. So it will give static int ways. Let's compile. It is saying error cannot find paths. PATHS cannot find symbol. INTJ, okay, INTJ paths. I've taken paths outside. Paths of IJ is equals to new int. Okay. Class error cannot find symbol, return paths INJ. So we have to return the return paths of x and y. So let's check. Yeah. So we have successfully computed. What is the test case? Oops. To check once. Static int ways x and y I have taken. X plus 1 to y plus 1 also have taken. For the paths I0 to less than equals to x I have taken also. Yeah. For moving towards left, 0. Yeah. For moving towards the top, I have also taken 0 and j. For the remaining points, I have taken 1 less than equals to x, and for the other remaining points, I've taken j1 to j less than equals to y. Yeah, j plus plus, that's also working. And for calculating the parts of I and j, what I'm going to do is parts of I minus 1, yes, into j plus parts of I into this one. So what is the problem? Again, in this question, what I think is I've missed this final keyword, and while doing this, I've made it instead of modulo, given the and symbol, and now we should submit. So you can see that we have successfully completed the number of possible paths. So if you want to know like how this is moving towards the left, you can see I is a variable component and 0 is a fixed component, so it is moving towards the left as I told. And whenever you can see the j is variable component over here, because j is representing the y-axis and 0 is the x-axis, which is constant, so you can move towards the up direction. For solving the remaining parts, we have to basically return the answer as the, you can see, find the number of paths. Whenever you will see a number of paths written in a question, you will always assume that it is asking you to give you the sum of the paths from left and down top. So basically for left calculation, we have taken a nested loop for paths like the remaining points plus I of j minus 1, and finally we are returning it to the modulo value. Thank you for being there.